You guys may disagree, but I really don't think it's too hard because it is a very typical conditional statement. The statements inside the conditional statement are also fairly, typical. One is an assignment statement where the right-hand side does not refer to the left-hand side, and the other one is a very typical one where the right-hand side refers to the left-hand side. So both of these we have done or seen many times, and this time it is just appearing, they are just appearing in the context of a conditional statement. But the way we tackle this problem is pretty much the same as we have talked about in the class. So if I were to go ahead to do this, answer this question, I'll use a text editor. The other thing is, without paper, the other class also has to do with the HTML editor in Moodle. And it's easy to use, once you get used to it, but some people have problems doing the indentation and some of the other stuff, like how do you write, to the prime. Okay, I think about 1/3 of the class asked me, where do I do that prime? F prime? Well, it's a single quote symbol. Yep.
Well, the nice part about the computer, at least, is if you realize you forgot something halfway through, you don't have to erase half your page and then insert it real quick.
That is true. Yep. It also permits copy and paste.
Yeah.
Yep. But sometimes copy and paste is bad because people just kind of copy it, or they can copy from the wrong part. So let me save this file first, so I don't forget to save it later on. I think I put everything into documents this time, so I'll save it as text.txt. All right, so this is for exam 1, question 2. Okay, so pre-1 is given. Pre-1 has to be given because you have to start with some assumption, and this time it is not just true. Okay, if someone gives me pre-1 is true and make that assumption, I will have to take some points off because it is clear in the question that pre-1 is already given and it is not true. Okay, but that won't be really a whole lot of deduction, but it will be some. So the next thing we want to do is to figure out what is pre-2 and what is pre-4. Pre-2 is the condition in the then branch right before we execute the statements inside the branch. So with pre-2, we have to state it is pre-1 because we have not yet have a chance to change anything. So it still has pre-1 as one of its components. At the same time, because I am in the then branch, I also have to say that x is greater than y, or the condition of the conditional statement has to be true. So partial credit will be given even if someone just writes this much, okay, without even expanding what pre-1 really is. Someone will get some partial credit here because this is illustration that person understands that in the then branch, or right before you execute any statements in the then branch, the precondition of the entire conditional statement has to be true, and the condition of the conditional statement has to be true. So after that, it's just mechanically expanding what is pre-1. Pre-1 is x equals j and y equals k. And you just append x is greater than y at the end of that. And that's it. That's pre-2. And then the next one is pre-4. If you guys want to work on post-2, that's fine. You can change the order a little bit. Pre-4 is almost the same thing. Pre-1 is still true at the time before I execute line 4 because I have not have a chance to change any variables at that point. But in this case, it is the negation of the condition of the conditional statement that is true, because otherwise I would not be in an else branch to begin with. So after that, this is also just an expansion and possibly simplification if you guys don't like the negation. So you can convert not x is greater than y to y is less than or equal to x is less than or equal to y. Any questions at this point? The way pre-2 and pre-4 are formulated has to do with the structure of a conditional statement. So that part is just, it's just the way it is, and there's no need to explain this part here. Now, post 2 and post 4 are slightly different because in order to derive what is post 2, it is an assignment statement, and to deal with an assignment statement, we have to look at the right-hand side and the left-hand side. So in this case, you can say right-hand side does not refer to the left-hand side, and as a result, use the forget rule. So that's basically all I'm looking for, is reasoning why you're using the forget rule instead of the substitution rule. So in this case, post 2 is the result of forgetting something in pre-2, but also adding the fact that at this point, y does equal to x. Any questions? Okay. In this case, so we just go ahead and expand what is pre-2, and this is where copy and paste can come in handy. But even writing is not too bad, because you can just it's not that much stuff to write. Oh, I forgot one thing, because I forgot to specify what I'm forgetting in pre-2. What should I write down here? I'm forgetting components that contain the variable on the left-hand side. So in this case, it is y. Very good. So we are forgetting components including y, and specify y does equal to x after that. So the forget operation will preserve x equals to j because it does not mention anything about y. This one we have to get rid of because it does mention y. This one we also have to get rid of because it mentions y. So the result of the forget operation is to only have x equals to j remaining, and after that we can say y does equals to x. So basically x equals to j, y also equals to j. Yep. Question?
K is just gone completely.
Yes, we have completely lost track of k because the only thing that contains k was y. And since we overwrote the value of y in a way that is not reversible, there's no way to know what is k anymore. Yep. And now we can work on post 4. Same thing. You have to look at the right-hand side and the left-hand side and see whether they are related. So in this case, the right-hand side refers to the left-hand side, and the right-hand side, we call it f of x equals x plus 1, has an inverse, f prime of x, which is x minus 1. Yep.
Do we have to write that right-hand side refers to the left-hand side thing?
Something to the same effect, which is something that we have talked about many, many, many times. Yes. You have to say something to the same effect. It does not have to be like that, but you can say.
But even if you're putting that in on your programming, does it actually recognize it as a command?
Nope, it does not. This is all reasoning on your part of analyzing the code. Okay, so now we know that there's an inverse function, which means we can use the substitution rule. So we say use the substitution rule. And the substitution rule states that the post condition is based on the substitution of the precondition. We find occurrences of the variable on the left-hand side, in this case it is x, and replace each occurrence with f prime, the inverse function, applied to x. And after that, it's just an expansion of what it is. So pre4 is x equals j, and y equals k, and x is less than or equal to y. We replace occurrences of x with x minus 1. And once you carry out the substitution, it becomes x minus 1 equals j, and y equals k, and x minus 1 is less than or equal to y. It really is just a text substitution of all the x's by x minus 1. If you leave it like this, that's fine. Okay, there's no need to do any simplifications. If you don't like the parentheses, you can just take out the parentheses in both cases because they are not needed in this case. All right, so I'm also interested in post 5. So the question is now, what is post 5? Yep, post 2 or post 4. Okay, because that's after the merge of the two branches. In other words, if someone just mentions this much, there's some partial credit already. If someone runs out of time, right after writing that particular line, that's worth some partial credit. because the next line is nothing more than just expanding those two post conditions. So in this case, we have x equals j and y equals x in one case, and then the other case is x minus 1 equals j and y equals k, and x minus 1 is less than or equal to y. That's the final answer. Okay. Are there any questions about number 2? No questions about number 2? Okay. Okay. Let's move on to question number 4, which is the last question. The last question seems a little bit hard, but if you just kind of reason it out and just say, okay, since this is the post condition of everything, if I go back one step, what do we know? Is it possible for me to know the value of z before this statement? That's the question. Okay. Now, in this case, you don't have to use the forget the substitution rule. You don't have to refer to the right-hand side and left-hand side. All I'm looking for is some explanation. As long as the explanation makes sense, it's fine. So let's go ahead and take a look at question number 2 and see what we can do. I will do it in 2 different ways because I know people have turned in both types of answers, so I want to talk about both approaches. So we'll say approach 1. Okay, this is the first approach to do it, which is the intuitive way of explaining it.
Special inspiration number 4.
Oh, Q4, sorry. Thank you. Okay, so now the question is, knowing that post 3 is like this, what is pre 3? Okay, so you have to kind of give me some explanations of, why do you think pre 3 is what it is? Okay, you look at line 3 is an operation that is not reversible. Okay? In other words, when I overwrite the value of z, in this case, there is no way for me to go back to the previous value of z because it is not reversible. Is that okay? So if anyone gives me a word that implies not reversible, irreversible, cannot find an inverse, there's no inverse, or something along that line that describes line 3, there's some point. Are we okay? Okay. And what is the result of that? As a result, we cannot know anything about z before line 3. Is that making any sense? Okay. So that means, if you look at post 3, can I keep y equals to k plus 1 before line 3? Sure we can, because line 3 does not affect y or k or x for that matter. So that's why we can still preserve all of those items, y equals k plus 1 and x equals k. So that can still be preserved. So the next time around, you have to work out what is pre-2. Optionally, you can say post 2 equals pre-3 because they are in a sequence. But that's optional. I'm not going to take points off because someone does not mention that. Yep.
Would it be okay to just state that we use the forget rule in line 3, which would mean that we didn't?
Yep, that would be fine. Yep. Because when you mention the forget rule, you're basically already telling me that the operation is irreversible. Yep. Okay, so now we have post 2. Post 2 is y equals to k plus 1 and x equals to k. The question is, can I go back to pre-2? And it's the same thing. Line 2 is an operation that is not, once again, reversible. It is not reversible because the right-hand side does not refer to the left-hand side. The only time it is reversible or possible